let's continue our work with factoring. So let's continue to work with factoring because it is so important that we know how to factor to solve equations using our zero product property, factoring to actually simplify in some cases too. So we're going to factor 4 tangent squared of theta plus tangent of theta minus 3. Now I like to factor this just the way it is. So I like to factor and say, okay, well the first two terms are going to get me back to 4 tangent squared of theta. So I can do that with 4 tangent of theta and 1 tangent of theta, because 4 times 1 is 4, and tangent times tangent is tangent squared. And then I can say, how do we get back to negative 3? Adding to be positive 1. Well, I'd probably put a 1 here so that I can get a 4 tangent of theta, right? And then I'd put a 3 here so I could get 3 tangent of theta. And I need the middle term to be positive, so positive 4 minus 3 would give me a positive. So 3 is negative and 1 is positive. That's how I would do this, because factoring through trial and error is really important, and once you master that skill, you can go straight to factoring these trigonometric trinomials. However, I do understand that some struggle with that. So another way, it's a little bit longer, but it's going to work. Another way to look at 4 tangent squared of theta plus 1 tangent of theta minus 3 is to say, let u equal tangent of theta. So now I have 4u squared plus 1u minus 3. Then factor. And when you factor, you're going to have 4u times 1u. You'll have that minus 3 and that positive 1. And then substitute back in the tangent of theta. So you'll have 4 tangent, so sorry for that, 4 tangent of theta minus 3 times tangent of theta plus 1, which is exactly what we got up above, right there. So why is doing this so important? Wow, okay. Let's show you why. Here's another factoring problem. Draw a line so I don't. So we're going to factor cosecant squared of x minus cotangent of x minus 3. Our problem here is that we have a trinomial, but we have 2 different trig functions. So we want to get the same trig function. So we don't want cosecant and cotangent. That cosecant squared comes from a Pythagorean identity. And that Pythagorean identity is 1 plus cotangent squared equals cosecant squared. So cosecant squared of x is going to become 1 plus cotangent squared of x. And then we have minus cotangent of x minus 3. So I'm going to write this in descending order and combine like terms. Cotangent squared of x comes first, minus cotangent of x, and then 1 minus 3 is negative 2. Now I'm going to factor this. How do I get back to cotangent squared? That would be cotangent of x times cotangent of x. And then how do we get back to negative 2? That would be a positive 1 and a negative 2. I just need to make sure I'm going to end up with a negative cotangent of x. Otherwise I have to change my signs. Negative 2 cotangent of x, 1 cotangent of x is negative 1 cotangent of x. and that's our answer. That solidifies it. We factored that to be cotangent of x plus 1 times cotangent of x minus 2.